Okay, let's get a start on Lab 5. And as it says here, we're going to be doing some things to make the Arduino-like functions work. And it says to take the program on page 63 of Chapter 3 and copy it into CodewWarrior. So what we're going to do is, what I've done here is I've actually zoomed out so that you can capture all this, and I did a right mouse click copy. And what I've done is I pasted that into CodewWarrior. Now CodewWarrior, there's a lot of stuff in here. Let's take a look and switch over to here. So one of the things that we want to do is we have a number of quotes, a lot of quotes through here, and we don't want to individually go and change them. So one of the things you can do is just actually highlight one of these double quotes, do a Control F, and under Control F what you can do is that is the quote that has to change, and you can say let's just change that to a real double quote and replace all. When we do that, it saves us a lot of time. Let's go back and take a look and see what we've got here. We've got some of them working, but then there's some other ones here, as you can see, that aren't. So we're just going to highlight that again, Control F one more time, and again what we're going to do is put in a proper double quote here and say replace all, and that should get all of the double quotes, but we still have single quotes, as we can see here. So let's close this, and what we're going to do is we're just going to grab one of these, Control F, again single quote this time, and replace all, and we still have a couple over here that aren't right, so we're just going to, let's close this, and we're going to Control F again, and we're going to replace that with a proper single quote and say replace all. Now there's a lot of other cleanup that we have to do, but that's done a lot of the things that we need in terms of quotes, and that's made things a little bit quicker. Now when you've got all this done, let's go back, and it's sort of like watching one of these easy bake things. I'm just going to delete this away, and I'm going to say OK, and I'll bring up the one that it should look like when we're finished. So this is like, you watch one of these cooking shows. So let me just open this project, and this is what it should look like when you finally got everything fixed. Let's just double click here and bring it up, and let's look at it here. So you should have a programmer's block, and the programmer's block should have something like program to demonstrate Arduino-like functions, and this program will illustrate, and the things that it's going to illustrate are diag, integer convert, and variable count. And you're going to have to add a library, e:/library_de1.h. That's one of the things you're going to have to add to the include section, or wherever your drive happens to be. Yours might be e:, it might be d:, it might be f:, it might be something like that. So you're going to have to put that in. Now what I'm going to do is show you how to add in. Now this was shown to you actually on one of the first videos that you saw on how to install CodewWarrior. So what we're going to have to do is under project up here, to put in the library, we're going to have to say project, and we're going to have to say properties, and under properties we're going to have to go C++ general, and under this paths and symbols. Now what I've done is, let's slide this over, and under libraries I've actually added it in here. Let me just delete it and show you again how to put this in. So I'm just going to delete it. So what you're going to have to do is, if you want to add something, you just go to the add. You're going to then go to file system, and you're going to go to wherever you happen to have this. Now I happen to have this on my E drive, and as I slide down here, there it is, library_de1.lib. Where did we get these? We got these from both the .h and the lib we got from the RAR files under the download section in Blackboard, and it showed you how to do this in the very first video. So let's just open this up, and we have to say add to all configurations and OK. As soon as we do that, we also have to say, as you might remember from the first video, apply and say OK, and everything then will be ready to go. So when you have everything ready to go, let's just hold our breath. Let's back up here a little bit, and let's just try doing a project build, because that's a lot of work that you had to do to get to this point. And let's hope that there's no errors with what we've got. So let's see, we're almost there. Yay! So what we're going to do at this point is we're going to do the regular run and so forth, and we're going to pick it up at that point as soon as we get to that done. And the first thing you're going to see is a splash screen here.
and it's going to then say what we had on the menu. We're going to see diagnostics, integer convert, and variable count, or varying count actually. So if we hit an A, what it's going to do here is it's going to show us what the current switch reading is, which happens to be 7F, as you can see on the switches. It also shows that in decimal. Right now, keypad, it's showing that I hit an A, and the A is 41 in hex and 65 in decimal. And we have push buttons. So if I press each of the 3 push buttons, I'm going to press the first one, or sorry, wrong one. Push button 3, which is the left one, middle one, and this one. And if you happen to push the other push button, the one furthest to the right, it actually resets the system and starts over, because that's a reset for our system. Now, what we're going to do is we're going to try B for integer convert. And it allows us to put in any number that we want. And if I put in 65535, it's going to show it here in hex, octal, on the red and green LEDs, and also on the 4 7-segment displays. Now, if I want to put in a shorter number like 4096, whoops, I got that wrong. Let's just hit this again, 4069. Let's do 4096. We can hit the number sign key here to say that's all we want to do, and it will show us a shorter version. So things like 255, hit enter, there it is, FF, 256, enter, and so forth. And if we want to get out of this, we hit the number sign key here, and it goes back to our menu. And our last one is varying count. So we hit C here, it's going to show a delay here of 80 milliseconds. And what it's going to do is, as long as I've got no push button, but if I push the leftmost push button, you'll see this number here change. And as it changes all the way down to 1, you're going to see the count speed up. If at the same time, or a little later actually, if I hold down the second from the left push button, this number will increase, and you'll see the count slow down on the LEDs and also on the 7-segment displays. And this will go up and stop really at 255. If we want to get out of this, we're going to hit the push button 3, the third one from the left. So what you're seeing here is we have a really nice menu. It's doing a lot of with only 3 actual functions being called up.
So if we want to take a look at our code here, let's just slide down. So it's doing all of this based on just calling up 3 functions. And the 3 functions are diag, integer convert, and variable count. And all it's doing here, let me just go back to our original code here. All it's really doing here is waiting for us to type in, let's slide up a bit here, it's waiting for us to take in a character from the keyboard. That's this Bob equals get char thing. And while we don't hit an A, B, or C, it's going to keep putting up this menu, putting up this menu. But when we do put up an A, B, or C, what it's going to do is we choose A, it's going to run the diagnostic function. And when we hit the number sign key, it drops out and then goes back up in here, comes back in. If we hit a B the next time, it's going to say integer conversion, and it's going to do that integer conversion thing. And if it doesn't have A or B, then by default it must be C, and it's going to do the variable count. Now everything seems to be working quite well, but the problem that you'll see over here is that when we're finished, it's going to leave some stuff on our 7-segment displays, LEDs, and so forth. So that's what the next part of the project is, or this little program is that we're supposed to do, is what we have to do is actually clean that up. Now it doesn't particularly care what we call this, but what we're going to do is we should do a little extra labeling up here. I'm just going to put in include section. Whoops. And right after this, if we're going to do a function, we should have a function prototype section. So what we want to do is just have a very simple function, and when we call the function, it's just going to clear things, so it's not going to take anything in, it's not going to generate anything out because it's going to the output. So let's call it void, just for want of a better name, clear and void. And that's what our code is going to do, is just going to clear out stuff. So we put a semicolon in here, and to make a function definition, let's just grab all of this down to, but not including this, Control C, and what we're going to do after our main here, we're just going to come down a little bit, and up in here we're going to paste this in. Instead of function prototypes, this is function definitions, and what we're going to do is just put in brackets. And what we have to do is clear all those displays. So the simple thing is RL, let's take RH equals 0. and that will make sure that we clear upper 2 red LEDs. We'll also do LEDRL equals 0, and that's going to clear lower 8 red LEDs. And then we also have LEDG gets 0, and that's going to just clear 8 green LEDs. And then we want to actually work on, let's just move this up a little bit so we can see what's going on here. We also want to clear off our 7-segment displays. So hex 3 equals 0x FF. Now we can make it FE, but so clear all 4 7 segs. Now again, people that are efficient, and let's try and be efficient, Control C, Control F, 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 F. We just make this a 2, a 1, and a 0, and we're pretty much done our function. So all we have to do is figure out where to put it. Now, if you're really clever, the thing is, and you take a look at this, we could put it maybe somewhere in here, but that's not that effective because every time you go around and make the wrong choice, it's still going to clear all the stuff, which is very inefficient in terms of runtime. So if you think about it, when you do make this thing and it comes out of here and it goes back up into this major loop, this is where we really want it here. So let's type in our function name, clear bracket bracket semicolon, and we'll just put in here clear all displays. So let's see if this is going to work. Let's come back out of this here. Let's try doing a project build and see if everything's going to work. So let's take a look and cross our fingers and see what goes on. So it's running. Come on, come on, come on. Let's go, go, go. And ta-da! Now at this point I have my program running, and I'll just focus on these displays over here. If I hit an A, you can see that all the stuff is going. If I hit another A on here, there's a 41. So we see all these things happening. I'm just going to hit the number sign key, and as soon as I do that, everything is cleared on the displays. If I hit B and I type in 65535, or I type in 44096 and hit the number sign key, if I hit the number sign key again, it gets out and again clears this. If I do my varying count here, it's going to count up, and if I happen to push this guy here to stop it, everything's clear. That is your first initial, and congratulations. Okay, let's take a look at the next thing we have to do. On question 4 here it says enter the program on page 72 of chapter 3. And what I've done, just to speed things up a little bit, I've taken this, I've copied and pasted it, and I've merged it a little bit with what we had up here. So if we take a look up here, we had lab 5 from before, so I pulled a little bit out of lab 5, and then I closed lab 5A, and we're now on lab 5B. So I've created lab 5B based on what we talked about before. Now if we take a look here at opening this up and taking a look, I've basically said the title is lab 5 question 5, and I said this program will put a scrolling message on the 7-segment displays. Now let's take a look. So when you clean things up, if the comments go too long, you can split it and put part of the comment on the next line, as I've done here. And let's take a look. So we've got data here. These are 4 blanks here. And the way this works is this. We're going to have 4 blanks on our 7-segment displays, and then it's going to say T. The T will come here, and then after a while it's going to slide over. And the way we're going to work it is this. It's going to put this message up first, which is 4 blanks on here, and then it's going to increase, and it's going to go from here to here, which is going to be 3 blanks, 1, 2, 3 blanks, and then the T and try. And then as it goes through the loop, it's going to go from here to here, and it's going to have 2 blanks TR, and it's just going to continue until the message try again comes up. And if you take a look here, we've got our devices in it, we've got this, we've got 0 to 13. So if we take a look, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what it's going to do is it's going to get here, and it's going to then be here, and it's going to print the next 1, 2, 3 elements, which means it's going to print 4 blanks. So the message is going to scroll across here, and then it's going to have 4 blanks come in so that the message scrolls right off the screen. Now the next thing to do is let's do a build on this and make sure it's going to work. So let's just go back here, and we're going to say project build, and I've already done that just to speed things up again just a little bit more. And what we're going to find down here at the bottom is we're going to have 3 errors, and the 3 errors that we have here are it's going to complain about delay milli and devices init. And as we saw before, these should work, but there's one thing we forgot. Do you remember what that was? Let's take a look and see. The thing that we forgot to do was to go under project. Let's do this again. Under project, we have to go under properties. Let's do that, project, properties. And what we forgot to do was to actually put into here on the C++ general, we forgot to put in our actual library. And that goes under paths and symbols, if you recall. So everything that we use that has our library, we're going to have to go to libraries. Notice it's not here. So we're going to have to add it. We're going to have to go to file system, as we did before. And once we get the file system, we're just going to find it on our memory stick. Now I happen to have it on the E drive here, so let me just slide over here a little bit. So it's right always at the bottom here, so I'm just going to click on that. I'm going to say open, and I'm going to say add to all configurations, as we've done before. And you're going to have to do this every time, and don't forget the apply and then the OK. And once we've done that, let's try compiling it again. Let's back up here, and let's do another build, project build, and this time there should be no errors. So even though we've included up here at the top, let me just slide up here as it's doing this, even though we've included the library de1.h, until we actually put the library in, it's not going to work. Okay, to run it, I'm just going to hit our resume here. I've set it up to be debug. So let's hit it and see what happens. Now what you're going to see is there's a try space again, and what it's doing is it's putting this stuff try again, then it's going to start over again and do this. And the way this is happening is if we take a look down here, it's starting from 0 to 13, so it's going through all the elements of the array, when it gets to 13, there's 3 blanks after that. So there's the 13, 14, 15, 16. So those are the elements of the array where the 4 blanks, and then it's just going to, when it finishes, it's going to go back and start this whole process again. Now, all we have to do really is just add our message and figure out these characters. So there's try again, and that's the original message, and between again and the next character we have to put a space. That's why I put a space on a separate line, and PLEASE. So altogether, when we take a look at it, we've added to the message, because if we don't change our loop here, it's not going to print out the whole entire message. It's just going to say try again, try again, try again. So what we're going to have to do is we have to figure out how many extra characters there's a space. 1, 2, 3, 4, 5, 6, 7 more characters. So we're going to have to change this number here to 20. So we're just going to run it and see what happens here. So as we're running it, the splash screen just came up, try space AGAIN space PLEASE, and then we're going to have our 4 blank lines, or 4 blanks coming in, and then it's going to start the message again. Okay, so what we want to do this time, as you can see this message scrolling over, it's taking 1 second every time through. Now what we want to do is use these 2 switches here to change the speed. So if these 2 switches are down, as it says here, off and off, we want to have 1 second. If we flip this guy up, we want to have a ½ second. If we flip this guy up, we want to have a ¼ second. Both up, we want to have an 1/8 of a second. So actual hardware, while we're running the program, will change the speed, which is kind of cool. The way we can make this work is to actually say delay milli. Instead of just 1000, which is a fixed value, we can shift this to the right based on the number of switches that we've got here. So if we shift it with these 2 switches down, what we're going to see is that this is going to give us 1000, which is 1 second between each shift. if we flip this switch up and we AND it so that we get rid of everything except these two, what we're going to see is it's going to give a half second between each switch, because 1,000 shifted to the right once divides 1,000 by half, and that's 500 milliseconds, which is fine. Let's flip these two down and put this back up, and if we do it by 2, shifting to the right 2, it makes this 1/4 its value, which is 250, which is a quarter second. And flipping this up, you can see that that's 1/8 of a second, because shifting it to the right 3 times is 1/8 of this value. So we can adjust the speed of this quite nicely just by changing the switches as the program's running. Isn't that cool? Anyway, once you've got that done, let's switch over here. We've got initial here. So as I said, if you want to get both of these initials, you can just show me this one running and I'll give you both of these initials. Now we will be doing the structured diagram for the program of question 3 in theory class, and it says to include a separate structure diagram for the function you created. Also, if we take a look at the next page here, it says draw a structure diagram for the program of question 5b of this lab as well, and again we'll be doing that in the theory class. The thing that we have to concern ourselves next with in the lab is to enter the program on the bottom of page 83 of chapter 4. So if we take a look, you can copy and paste this in. And what does this program do? It takes the keypad digits 0 to 9 and displays them on the left 7-segment display. But what you're going to find as well is we're going to be making some modifications to this. So as we go through here, if you want, you can get the first initial just by doing that and just showing it running. But if you show all of these modifications all the way down here, notice there's checkpoints for each time you display something. When you get right down to the bottom, if you can get everything working down to here and show me just this, I'll give you initials for everything on this page. And all this will be basically what it was before. Takes hex key presses from the keypad and sends them to the 7-segment displays and the LCD. It also updates some stuff on the LEDs. Now some of the things that you can run into problems with, again, is not only the double quotes that you've got here, but further down in your code you're going to see single quotes as well. So make sure you got all those cleared up. You should have it cleaned up to look pretty much the way you're seeing it here. If we go back to the debug, what I've done is to make it a little bit easier, I've actually got the code running now. And if we want, we can just start doing things like this. Let's just press the 1 key. Now watch what's happening on the 7-segment display. So I'm going to press 1. I'm going to press 2, I'm going to press 3, I'm going to press A. Now when I press A, the 3 stays on the screen, but you're going to see a green LED come on. Then if I do 4, the green LED goes out, 5, 6, and then the B. And when I do the B, the green LED comes on again, 7, 8, 9, C. The green LED comes on again because it's not valid. Star green LED stays on, 0 it goes off, number sign and D. So as I press all of these keys, all the valid keys from 0 to 9 will display on the left 7-segment display, but anything that's not 0 to 9 will cause the green LED to come on, and that's how your program is supposed to work. Now the next enhancement we have to do is basically just take where it has these 2 lines of code in here and change it into a function. And the function call is just going to be key press equals get char. So here's what we're going to do. Let's just go take a look at our code, and I've already put in the changes. So the first thing that we have to do here is put in a functions prototype section where we say unsigned char get char void, because it's not going to take anything in it, but it will return a char. So that's the first thing we're going to have to do. Then if we take a look here in our main, we're going to replace those 2 lines of code with key press equals get char, and our code here will actually look like this. It doesn't matter what we call our variable, but we're going to have to say something equals get key, something equals keypad, and we can use any variable we like, and I'm using input. But whatever variable you like, you're going to have to define here inside this function and then return that value back to the calling function. Let's take a look at it running. So if I just happen to press a 1, 2, 3, A, works pretty much the same as before. So that's your next initial, but as I said, you can do all of these and just keep working, and when you're finished you can show your final version to your instructor. Now on part C here, what we have to do is we have to make any references to LEDG underscore LED0 to LEDR underscore L9. And you might be wondering what these are, but if you remember, if we wanted to turn on and off the least significant green lead in the past, we had to OR to turn it on and to shut it off. But we have these shortcuts here that allow us to change LEDG underscore LED 0 to 1 or 0, which individually turns on or off the green LED, the LSB green LED, without affecting any other bits. And so all we're going to do is make references for the green LED, the LSB green LED, to be the MSB red LED. Now, as we go through this, it also says we're going to, instead of just having, say, if we press a 4 on the keypad, we don't just want the 4 on the left 7-segment displays, we want a 34, which is the hex equivalent for 4, showing up on the right 2 7-segment displays. Also, the 4 we want to show on the lower red LEDs, and we want the 34 to show on the green LEDs. And that's what we have to do to get the next part working. So let's take a look at the code. And so let's see what's going on here. If we look down here, it basically said if the key press is less than 0 or the key press is greater than 9. And what does that mean? It means that the key press itself, if it's not 0 to 9, is invalid, so we're going to turn on the red LED. Further down here, after it gets out of this loop, it says, okay, if the key press is in the range of 0 to 9, then it gets down here and it shuts off our red LED. And that's all good. Now what we want to do is, if you take a look at what it's doing here, hex 3 is display table of whatever the key press is. And if you remember what key press is going to be a number from 30 to 39 if it's a digit 0 to 9. And that's the only way it's going to get down here, is if it has 30 to 39. Now if we say key press minus 30, key press of 4 will be 34 subtracts 30 will be a 4, and it looks up the pattern for a 4. Now there's a couple ways we can do this. We can just subtract 30, or we can AND it with 0F, which will be basically the same thing. So what we're doing here is we're saying, okay, we're going to display on the left 7-segment display the actual digit, and on the 2 other displays we're going to put a 3, and then we're going to put the actual other digit. So it'll be 4 here, 3, 4 here, and so forth. Now also here on the red LEDs we're going to put key press ANDed with 0F. And why are we doing that? Because we just want the 4. So 34 ANDed with 0F will give us 04. LADG is going to get key press, which will be the 34, and that should actually work. So if we just run this up now and take a look, if I was to press a 1, I'm going to get 1, 31 here, I'm going to get a 1 here, and 31 here. If I press a 2, I get 232, 232, 3, and so forth. If I hit an A, notice that my left LED is on the red LED. So that's how it works. So any number I push, including 9, I'm going to get a 9 here, 39, 9, 39 here, and that's what you need for your next initial. Now on part D, what we have to do is add to our code to position the cursor at 2, 6, which is the third row from the top, 7th character from the left on the LCD. And what we want to do there is when we hit a 4 on the keypad, we want a 4 showing up at these coordinates, 2, 6. We want an equal sign beside it, and the actual 34, which is the hex equivalent, showing up beside that as well. Let's take a look at the code that does this. And we can see here to position the cursor, it's just called LCD set cursor, and you can see under here it's documentation in the .h file. If we want to take a look at it, shows how this works. It positions the cursor based on that. So it's going to position it at 2, 6. The LCD write character actually writes the character 4, so if we hit a 4, it's going to write 4 there. Then it's going to write the character equals when we use write character, LCD write character. If we just do LCD write, it actually writes a 2-digit hex value. So let's see what that looks like when we run it. So if we run it, and if I happen to press a 1, I'm going to get a 1 equals 31, and I'm seeing exactly the same thing on the other displays, 131 and so on as before. If I hit a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 0, if I hit any other character, I don't get anything coming up on the display until I hit another valid character. And that's how this part of the code should work. Okay, the last part here is if we hit the star key, it should clear the lower red LEDs, the green LEDs, the 4 7-segment displays, and the LCD. But if you remember, only 0 through 9 should not turn on the most significant red LED, and this key is definitely not 0 to 9, so hitting it, even though it's going to clear all the displays, it should still leave on or put on the most significant red LED. Let's take a look at the code that does that. So over here, what we're saying is if the key press is not a valid key press, and that's where we're going to run into here, that we're going to turn on the most significant red LED, but we also want to check to see, because it's also an invalid key press in terms of 0 to 9, we want to take a look at the star key. So if it is a star key, we're going to clear all, and otherwise, because that's in this loop, get a character. If it's a star key, clear all, and make sure the red LED's on. So we have to make sure both of those are on. Everything else is going to stay the same. Let's take a look at the clear all function. Some of the things we have to remember about clear all is we're going to have to make it a function prototype and a function definition down here. And all we're going to say is the lower red LEDs are going to be cleared, the green LEDs are going to be cleared. And notice what we have here is CLR-SEG. CLR-SEG is a built-in function right in the Arduino library that clears all 4 7-segment displays. Isn't that handy? So we don't have to do hex 3 equals FF or all that stuff. We can just do that. So as we run this thing up, and we got our splash screen here, I'm going to hit a 1, a 2, a 3. Everything's working fine. If I hit an A, the red LED just went on, most significant. If I hit a 4, 5, 6, but if I hit the star key here, everything clears, but you should see at this point your red LED coming on. If you do, then what you're going to have is this last initial. So if you have all of these features built in and just show your instructor this, you're going to get the initials for all of the remaining page of Lab 5.